Hello there. So we are going to look at graphs today. And motion graphs tell us a lot about what is going on. Just take a look at this simple graph here. And again, this could have been any one of the graphs that you've done in the lab in science and other classes where, this could have been days of the week and plant growing or something like that. But in our case, we're looking at the first part of physics. We're trying to describe motion, and one of the ways we do it is through graphs. The other way is, of course, through motion diagrams, where I'll discuss that in a different class, and of course, tables. But graphs are really, really powerful. So I have an object that started at time 0. He was at rest, so it's his little thing, and he's sitting right here. And then at time t equals 2 seconds, he's at 10 meters. So, he's 10 meters away from where he was. And then 2 seconds later, he's 20 meters away from where he was. And so looking at the simple graph, and this is what we call a position time graph, is telling you what the car was at what time. Now, obviously, if the car continues to go at this rate, you could predict that at 6 seconds, he'll probably be at 30 meters. And usually this, when time is here, this is a rate of some kind. And if you remember, the slope is your rate. So you could easily see that he goes 10 meters in 2 seconds. 10 meters in 2 seconds. So his speed must be 5 meters per second, right? The 10 over 2, 5 in the meters over seconds. And that's how fast he's going. You could also find the slope and say, what's the slope? Well, the slope would be the rate, which would be the speed. Again, and so if I were to say I want to take these points and that points, that would be 20 minus 0 over 4 minus 0, which is again 5 meters per second. But that's your simple graph, and you could really describe what's going on, what's going to happen, where it probably was at 3 seconds. I mean, pretty much everything. And then there's other interesting things. You see, the slope is a constant slope. That means the speed is constant. Okay, that means the speed is not changing. It's a constant 5 meters per second. Every second it'll have gone 5 meters. Really, really, really simple motion graph. And if I wanted to see what is the position of this object going to be at any time, so let's say I want to write, and then I'm going to become a little mathy now. If I wanted to write x as a function of time, remember doing that in math? Sure you do. Maybe before you were writing f as a function of x, right, where f of x was always up here and x was here. Well, we always put our time here because we're looking at motion. Just makes sense to put time here. So if you look at it, your position of x at any time is going to be 5 times t, and that's it. 5 meters per second. And so you say, really? It's like, yeah, look, your position. Let's say if I was making a table of position versus time. So at time t equals 0, 0 times 5 is 0. At t equals 1, you're at 5 meters. At t equals 2, you'd be at 10 meters. I'm just multiplying here. 3, 15, 4, 20. This is describing exactly the same thing that is describing. And just to bring in motion diagrams at this time, motion diagram for this something would look just like this. Where this distance here could be 5 meters, and this is a probe or a strobe that goes on every 1 second. So every 1 second it tells you the car was here at 0, then here at 5, 15, 20, 25. And so that would be a motion diagram. And it may not necessarily have these numbers on here, but you would either know what time it takes for each of these dots. And so an object moving at constant speed would have these dots at constant distances apart. Think of it as your car leaking oil. Not a very nice thought, I know. But if your car were leaking oil and it were traveling down this way, that's what the pattern would look like of the oil drops as it went down. So that would be a motion diagram. That's a table, and that's a graph, and that's an equation. And these are the 4 ways that you can describe motion. Here's 1, 2, 3, and 4. The same motion is described by all 4 of these things. And so we see that these are the different ways to describe motion. I'm going to continue on and show you some really simple stuff right here with motion graphs on the next one.